Alright, how's it going? So this is the video for 7-7 areas of circles and sectors. There it is. I've done some fancy work with the copy machine. I've taken out quite a bit. If you guys have the book, feel free. You can just totally use the book. Skip these two videos. Just fill in these notes here, or just move on straight to the exercises. This is for those of you who don't have a book, or if you want some extra help going over some of these concepts. So this first little bit, we're talking about area of a circle here. Area of a circle. You guys probably remember it's going to be pi r squared. So here's our circle, the center O, and then it has that radius. The area of a circle is equal to pi times the radius squared, pi r squared. Really simple thing to memorize. I really suggest memorizing that. The book goes into some explanation of how they got that. I will not cover that here. I'll just go into some applications. So the first one is going to be how much, this should be much more pizza is in a 12-inch diameter pizza than a 10-inch diameter pizza. So how much more is in a 12-inch diameter pizza than a 10-inch? So let's draw out our little pizzas. One has 12 inches, the other is just 10 inches. So we notice area is going to be pi r squared. I'm given diameter, so I need to find radius for each of these. Your radius is always going to be half the diameter. So the radius of the big pizza, that's 12 divided by 2, that's 6 inches. And the radius of small pizza is 10 divided by 2, that's 5 inches. So let's figure out the area of each. We'll figure out the area of the big one and the area of the small one. So this is going to be pi times 6 squared. This will be pi times 5 squared. Does it want us to approximate? We'll approximate at the end. So 6 squared is 36, so this is 36 pi. This is 25 pi. I want to find out how much more pizza is in the big one than the small one. So this big one is 36, the small one is 25. I can figure out how much more is in this one if I find the difference between the two. Difference keyword, that means subtract. So I'm going to do 36 pi minus 25 pi, that's 11 pi. And then once we approximate that, we get 35, about 35 inches square more pizza. Okay, so a square inch is about that big. It's an inch, so it runs an inch and it goes down an inch. Square inch is about that. So imagine 35 of these. So maybe like this much. That's how much more pizza is in a 12-inch pizza. So if you're looking, I mean, that's a significant size pizza. So if you're looking at your pizza menu and you're going, oh, the 12-incher is $12.99, but the 10-incher is $10.99. Oh, it's so much cheaper. It's $2 less for only 2 inches. Think again, because the area of that 12-inch pizza is a lot bigger. You probably know this. You probably consumed a 12-inch pizza and you consumed a 10-inch pizza, and you know anecdotally that the 12-incher is a lot more pizza. Well, here it is in the math. The 12-incher is 35 square inches larger. Alright, so the sector of a circle is a region bounded by an arc of the circle and the two radii to the arc's endpoints. You name a sector using one arc endpoint, the center of the circle, and the other arc endpoint. The slice of the pizza at the left has a sector XOY of a circle O. So imagine this is your slice. The whole thing is the whole pizza. It's not drawn. This slice is just a sector of that pizza. The area of a sector is a fractional part of the area of the circle. The ratio of a sector's area to the circle's area is the measure of the arc divided by the entire pizza, which has 360 degrees. So let's look at this. The area of a sector. Here we have our entire circle O, and we just want the little sector from A to B with the radius R. We're finding this area. So to get the area of that sector, AOB, that's AOB, the area is going to be the measure of the arc AB divided by 360 times the area of the entire circle, which is pi r squared. So just like how we were doing last time, finding how long the circumference is of just a little bit, you want to find the area of the entire circle and then just divide it by how much of this angle is part of the circle. Okay, so let's look at an example. Go ahead and flip the page. Hang on, don't flip the page yet. Let's just do it right down here. I left some extra space. Let's go example. Say you're given a circle O, and you have a sector ZOM. This is your sector, and its angle is 72 degrees. Okay, so from Z to M, we're looking at a 72 degree chunk. The radius is 27 meters. So I want to find the area of this sector. Okay, so I first need to figure out how much of the circle this sector is, like how many degrees of the circle this is. So this is 72 degrees of the entire circle, so that's of 360. 72 divided by 360. I'm hoping that's a nice number. Let's figure it out. Let's open up the calculator here. 72 divided by 360. Oh, how about that? It's 0.2, so this is a fifth of the circle. Alright. So that's a fifth of the circle, or it's 0.2 of the circle. Now I'm going to find out the area of the circle. The area of the circle is going to be pi r squared. So you do pi times the radius squared, so that's 20 squared. So that's going to be pi times 400. So we do 400 pi, and we're going to multiply that by how much that sector takes up of the circle. So basically the fractional component of the circle, that this sector is a fractional component. We found that it's a fifth of the circle. So I'm going to take the 400, I'm going to multiply by a fifth, or 0.2, and then you'll get 80 pi. Okay, so the area of this sector is 80 pi, and your units are going to be centimeters squared. Okay, go ahead and flip the page. Okay, now this is where we're going to split up the sectors. This is called a segment. Okay, a part of a circle bounded by an arc and the segment joining its endpoints is a segment of the circle. To find the area of a segment for a minor arc, draw radii to form a sector. The area of the segment equals the area of the sector minus the area of the triangle that's formed. Okay, so we get this sector here minus the little triangle that's formed there. That will give us the segment, or like the cross-sectional slice of that circle. So let's look at a circle here, circle O, and it's got a right angle. AB, and the radius is 10 inches. So the first thing I want to do is find out the area of the sector, this chunk right here, area of my sector, and then I'll minus the area of the triangle that's formed within that sector, and then that should give me the area of the segment. Okay, so the area of the sector first, let's go ahead and do that first. This is a right angle, so this sector here is a fourth of the entire circle. Okay, so get that, I'm going to do 90 divided by 360, that's a fourth, or 0.25, 25% of my circle. The entire circle is pi r squared, so that's going to be pi times 10 squared, that's 100. The entire circle is 100 pi. We're going to multiply it by a fourth, since this is only a fourth of my circle. So the area of my sector is 25 pi, we're looking at inches squared. So the area of this sector is 25 pi inches squared. Next I need to find out the area of this triangle. Remember, triangle is 1/2 base times height. My base here is 10 inches, and the height is also going to be 10 inches, since that's also radius. So this is 1/2 times 10 times 10. So that's going to be 50 inches squared. So what we're going to do is we're going to do this number, 25 pi inches squared, minus this number, 50 inches squared, and that should give us the remainder, the area of the segment. So, don't exactly know what 25 pi is, so I'm going to punch it in a calculator. 25 times pi, press enter, and we're looking for the nearest tenth here. So this number is going to be 78.5 minus that 50. So the area of our sector is 28.5 inches squared. Alright. You can rewatch this part if you're confused, or just stay tuned for those tutorials and I'll go over finding some of the areas of the sectors. Alright guys, thanks for watching.